The world as we know it may be hiding an unexpected secret that could change everything we thought about its origins. For centuries, people have relied on the Big Bang theory as the cornerstone of the universe, a theory supported by many theories and nearly all scientists agree. What if the fabric of our reality is more mysterious and complex than we thought? Recent discoveries by the James Webb Space Telescope have shocked the scientific community and revealed galaxies before the Big Bang. These findings don't just challenge our understanding. They threaten the entire fabric of the world. As we look deeper into the world, these questions arise. Could it be that our understanding of time, space, and the moon are not the same? And if so, what does it mean for our understanding of the world? Imagine a world where the laws of physics, as we know them, are in doubt. With an unprecedented ability to peer into the past, the James Webb Space Telescope has discovered galaxies that defy the universe's timeline. These galaxies, older than the universe itself, have sparked a debate that may lead to the most important paradigm shift in the history of science. What if the big city didn't happen? What if the universe is older than we thought, or was in a different state before the Big Bang? As we explore these amazing discoveries, we find ourselves on the brink of a scientific revolution that could redefine our place in the world. For nearly a century, the Big Bang theory has been the most widely accepted explanation for the origin of the universe. Conceived by Georges Lemaitre and supported by the observations of Edwin Hubble, the book states that the universe began as an individual about 13.8 billion years ago, and that it rapidly exploded in a big explosion that created the things that all the energy we know. This theory has shaped our understanding of the universe, from the formation of galaxies to the behavior of distant moons. However, the James Webb Space Telescope has captured images of galaxies that point to an ancient universe that is believed to be the origin of the Big Bang theory. One of the most amazing discoveries was made by Harvard University student Rohan Naidu and his team, who identified a galaxy called Galaxies Z13. This galaxy is believed to have existed 200 million years after the Big Bang. The existence of such galaxies early in the universe's history challenges the idea that galaxies last billions of years. After this discovery, another galaxy was discovered called GN-Z11, which is estimated to be 13.4 billion years old. The findings suggest that stars and galaxies form much faster than previously thought, raising questions about the validity of the Big Bang theory. The implications of these findings are profound. If galaxies like GN-Z11 and Galaxies Z13 existed shortly after the Big Bang, stars and galaxies formed faster than current models suggest. This has led some scientists to reconsider other theories about the origin of the universe, including the concept of an infinite universe, and the idea that light does not last forever. Swiss physicist Fritz Zwicky, a contemporary of Albert Einstein and Edwin Hubble, proposed the spent moon theory nearly a century ago. Zwicky thought that as light travels through the universe, it loses energy and moves to the red end of the spectrum. This idea, long rejected by the scientific community, is now being reconsidered based on findings from the James Webb Space Telescope. The faint moon theory provides an alternative explanation for the observed redshift in distant galaxies, a phenomenon that is thought to be a sign of the universe at large. According to Zwicky's theory, redshift may not indicate that galaxies are moving away from us, but rather that these galaxies lose their light intensity over time. If this is true, it means that the universe may not be expanding, or at least not in the way we currently understand it. This could have important implications for our understanding of the universe, forcing us to rethink the age and size of the universe. The James Webb Space Telescope has discovered galaxies like Sirius 93316, which is estimated to be 13.8 billion years old, nearly as old as Earth itself. This discovery caused a great debate in the scientific community, as the theory of the beginning of the universe was challenged. How can the galaxy be a city at the same time? Some scientists believe that this is a sign of the past, that the Big Bang may not be the special event we once thought. In addition to these observations, galaxies such as HD1, one of the brightest and oldest classes known, and MAX 0647 JD, an evolved galaxy, complicate our understanding. To the old world, these galaxies show a level of organization and development that is impossible for their age. If these galaxies were formed before or during the Big Bang, our entire understanding of the universe would be disrupted. This has led some researchers to investigate whether our measurements and perceptions of the moon and time are wrong. One of the main ideas put forward was the different nature of the moon in the first world. As the moon travels from these ancient galaxies into space, the universe expands and the moon reaches the red end of the spectrum. But what about this translation? What if the changes in the moon that we see today happen that we don't fully understand? Some scientists, such as Canadian physicist Rajendra Gupta, have suggested that small changes in our understanding of planetary variables could lead to an old age. According to Gupta's calculations, if certain variables are adjusted, the universe could live for 26.7 billion years, up to 40 billion years. If these alternative theories are correct, the implications for our understanding of the universe are dire. It not only means that the universe is older than we thought, but it also indicates that there may be different fundamental forces and constants that govern the universe than we have always thought. This could recapitulate everything from the nature of dark matter and dark energy to the behavior of black holes and the end of the universe. In this context, the work of researchers such as Michio Kaku, who has long advocated the unification of quantum physics and classical physics, becomes more and more important. Kaku has argued that the apparent contradictions between these two branches of physics point to a flaw in our understanding of the world. The observations made by the James Webb Space Telescope can provide the evidence needed to fill this gap and lead to a new theory that unifies the forces of nature and explains the true nature of the world. However, not all scientists are ready to abandon the Big Bang theory. John Mather, head of the James Webb Space Telescope program, believes that the Big Bang still provides the best explanation for the origin of the universe. Mather suggests that the galaxies discovered by Webb might have formed faster than previously thought, but that this does not necessarily disprove the Big Bang. Instead, it might require us to revise our understanding of the timeline of galaxy formation, rather than the entire cosmological model. In contrast, Sir Roger Penrose, a British physicist and Nobel laureate, has proposed an entirely different model of the universe. Penrose's theory of a cyclical universe suggests that our universe is just the latest in a series of cosmic cycles, each beginning with a Big Bang and ending with a collapse into black holes. According to Penrose, these black holes eventually evaporate, giving rise to a new universe in a process he calls conformal cyclic cosmology. This model could explain the existence of galaxies that appear to predate the Big Bang, as they might be remnants of a previous universe that have carried over into our own. The idea of a universe is not new, but discoveries made by the James Webb Space Telescope have given it new life. If Penrose's theory is correct, it means that the universe has no beginning and end, but an endless cycle of creation and destruction. This has profound implications for our understanding of time, place, and the way we are. The arrival of the James Webb Space Telescope has revolutionized our understanding of the universe, revealing galaxies that challenge long-held beliefs about the formation and evolution of the universe. When researchers examine the data and amazing images from the Webb, the results of these findings go beyond academic interest. Each new finding ignites debates among researchers, with some clinging to traditional models like the Big Bang while others advocate for alternative theories, such as Fritz Zwicky's concept of tired light or Roger Penrose's cyclical universe. This scientific tug-of-war reflects the dynamic nature of cosmology, where the quest for truth often involves unraveling complexities that defy conventional wisdom. As more discoveries unfold, the landscape of modern astrophysics may very well be reshaped, leading us to a deeper understanding of our place in the universe and the fundamental laws that govern it. The universe is revealing its secrets slowly, and the James Webb Space Telescope is at the forefront, guiding us through this uncharted territory of cosmic revelation. As we continue to explore the universe with the James Webb Space Telescope and other advanced instruments, we are likely to uncover even more evidence that challenges our current understanding of cosmology. Although the final answer lies in revising the Big Bang theory, adopting different models such as the moon or the tired universe, and discovering new principles of physics, one thing is certain: we are almost ready for science. This is a revolution that could change everything we know about the world.